Hello, this is Mr. Avant, and it is February 18th, 2021, and it's been a long week. It's been cold weather, no power. It was Mardi Gras holiday, but it was not a very fun one. And then we lost a day of school, and now we're returning virtually, and I'm trying to scramble and get ready for tomorrow's virtual school. But in the meantime, I had some students from last year who have been asking me about doing some algebra problems, and I'm really excited because some of my fourth graders are actually starting to see algebra in their success maker because they've moved ahead so far. They're looking at sixth and seventh grade pre-algebra type work, and this particular student actually has some high school algebra problems. So I wanted to do a brief little demonstration on how these work and some basics about algebra. Nothing complicated, just really easy stuff so that when you look at Success Maker, you'll have better success and you'll understand what you're doing with some basic rules. So let's go ahead and take a look at that. I already started working on one of them here, so I'm going to flip my camera over, and you can see that I started highlighting this. I printed this out from my telephone, so it was kind of blurry, but I'm trying to sharpen it up. This is actually, this first one I'm not going to spend a lot of time on. It's called a trinomial factorization, or we could call it a polynomial quadratic. If there was an equal sign in there, it would be a quadratic equation, but it is a polynomial or a trinomial factorization problem. It says factorize. Factorize means to create a multiplication problem, and as you can see, that's the first thing we need to talk about. So whenever you have a number with nothing in between it next to a letter or another number, or parentheses that are next to each other, we consider that a multiplication problem. So instead of saying 2x squared, we're actually saying 2 times x squared. Instead of 13x here, we are saying 13 times x. Okay? That is a big rule. That's a big game changer. So when you see a problem like this, what is D right here, 7D? D would have to be a number that you would multiply times 7 to get 35. So when there's nothing in between the letter and the number, we need to find a value for that letter that gives us something for a multiplication problem. So 7 times 5 equals 35. Therefore, D equals 5. Very simple idea. This variable is D. So whenever we have a letter representing a number, that's another big thing in algebra. We have letters that represent numbers. This is very helpful when you are in the real world, when you are trying to plan how certain devices will work, or if you're testing something, or if you're trying to get a certain outcome. You need real-time data. Like if you're testing a motor, you need to know how much energy it takes, what is the energy output, what is the speed, maybe what is the temperature. If you have a formula that determines something, you can plug in those different values depending on what those values are, and use a letter to represent what they mean. So you get the same effect every time. The same thing could be said for cooking recipes. A lot of things can be represented in a formula with these letters, and you put the value of the letter in, it gives you a different result. That's what we're trying to show you in Success Maker in fourth grade, where you have the same rule or pattern and you plug in a different value each time to get a different result. But you are using the same proportion of multiplication or addition, subtraction, or division. So let's take a look at this now. We know we have to create a multiplication problem out of this because two numbers multiplied times each other would be a factoring. So to factorize this, we need to create a situation where things can be multiplied. So we do that by creating two sets of parentheses. And the first part of the expression, 2x squared, we can find simply by multiplying 2x times x. Now, whenever there's just a letter there, we assume that there is a 1 there. 1 times x equals x. We can use that to help us whenever we're adding these as well. So 2x times 1x equals 2x squared, meaning x times x is squared, just like in your area formula. And then 2 times 1 equals 2. 2x times x equals 2x squared. Now we have the 13x here. Now this situation, with this middle one, we find that by having something else in here that we add to it. And there's a lot of steps to this. I'm not going to go over it, but this is simply how I find the answer quickly. I need two numbers that add up to 13 that will be multiplied times x, or by another number that can result in the same answer. So let's say we'll use 10 plus 3 here. 10 plus 3 equals 13. So I'm going to put a 5 over here because 5 times 2x equals 10x. And then I'm going to put a 3 over here. And 3 times x equals 3x. So when I add 10x and 3x together, I'll get 13x. And then lastly, we need something that adds up to 15. Let's see if it works. So the way that these work, whenever you have these two addition problems and in parentheses multiplied times one another, we do it step by step. It's 2x times x, then 2x times 5. 2x times 5 is 10x. Okay, next we're going to do the 3. So you multiply 3 times each of these and have an addition sign in between. So first we have 3 times x, or that's 3 times 1x, equals 3x. You add these two, that gives us our 13, okay? And then we're going to do 3 times 5 equals 15. So we're almost there. If I simplify again, which means I add these two, simplifying means to get something down to its most basic form that can't be changed, its simplest form. So in this case, I can add 10x and 3x and make a simpler statement by saying 2x squared plus 13x plus 15. There we go. Okay, that one's done. Let's look at the next one. We have number 28, whatever this came from. 28, it says simplify. Simplify means to make an expression that is at its most basic, meaning that there should be something here that we can change to make a simpler expression without all these numbers and letters. We should be able to reduce it down to something more simple. Reducing is another way of saying it. Reduce. Okay, so we have x squared plus 8x plus 15. This is one of those trinomials we were looking at earlier, but we can do some things to this to simplify. First of all, I see an x squared and an x here. I see a 4-8x and an 8x and a 4x here. Since these are added at the top and added at the bottom, we can change these. I could divide 8x by 4x and come up with a simpler solution. All right, the x squared we might have to keep the same. Let's see. And then 15 over 12, that can also, those have factors. Those have common denominators. We could factor this into a simpler fraction. So let's see what we get so far. I have x squared. Let's break it apart. That's over 1 plus 8x over 4x plus 15 over 12. Okay, now let's move down here. We're going to keep rewriting it until it makes sense. So I could say x squared, let's see, 8 divided by 4x. 8 divided by 4 is 2, so I can call that 2x. And 15 over 12, if I were to factor these out, 3 is a common denominator here. If I divide 3 top and bottom, I get 5/4 now. 5/4. Now 5/4 is an improper fraction. I could say now, we're almost there, x squared plus 2x plus 1 and 1/4, because 4/4 is 1 whole and there's one more fourth, so there's our expression. We've simplified it to its most basic expression. Okay? Let's look at this one at the bottom. Simplify. Again, we have a trinomial on top, 2x squared plus 9x plus 10 over x squared minus 4. Now, these x squares here are common, so I could put 2x squared over x squared. Guess what? X squared over x squared equals 1. That cancels out. That becomes a 2. Okay, next I have a 9x, just say it's over 1, and then I have plus 10 over 4. 2 would be a common denominator here, so this can be factored out into 5 halves. So let's come over here and rewrite that. I have 2 plus 9x plus, now take that 5 halves, that's actually 2 and 1/2. So I simplified it again. This is quite common when you see the same thing top and bottom, they can be eliminated like that. Oh, and I forgot, that's not a plus sign, that's a minus at the bottom. That might create a problem for this overall. We'll just say minus 2.5. Now, there might be other solutions to these. I just went over some of the basics of how especially when you put two things next to each other, like 8x that is actually saying 8 times x. Whenever you have the same things top and bottom, remember your factorization from our simplifying fractions. It's the same idea. When you have a something top and bottom, they can be factored out. This 10 over 4 can be simplified into 5 halves and then into 2 1/2. These are all things you saw in 4th grade, and hopefully this will help you on some of your algebra problems in the future. Thank you.